All right, well, hello, Honors Algebra 2. We are working on our last section of the notes for Unit 12. We're going to be talking just a little bit about solving trig equations. This is our last section of notes, so this will be the last video that I'll be making for this year. You can think about it as the last class period of the year of sorts, if you want to think about it that way. We probably would have had some sort of a celebration or something fun that we would have done in class to celebrate that. Unfortunately, we can't do that. But here we are. Here it is. We'll get it knocked out. I'll have the final review posted for you sometime later this week. And then your final you can take anytime next week if you're planning to do that in order to try to raise your grade by replacing one of those other test scores. I may or may not make some other videos with some announcements or different things for you, but this will be the last notes video of the year. All right, here we go. So 12.3, solving trig equations. In parentheses, I put again. We did this back in Unit 9. We're going to be looking at a few new things in this section, though, that are a little bit different from what we saw in Unit 9, some of which will involve the trig identities. So we kind of had to wait to do this until now. Just to get you warmed up, though, let's go ahead and solve a few of these equations. We're going to be solving them on the interval 0 degrees to 360, so thinking about the unit circle. In fact, if you've got your unit circle, I would recommend going ahead and getting that out at this point or pulling it up somewhere on the internet or on your phone. Or, if you've been practicing the unit circle, you could go ahead and write it out real quick and see how quickly you could do that, because we will be using it. I don't have it pulled up. I'm just going to be referring to it. But if you have any questions later on how to use that, let me know. All right. So pause the video, do that warm up, and then we'll go through them. Okay, so for part A, 2 sine of x plus 1 equals 0. Let's start to solve that. So we'd have 2 sine of x is equal to negative 1. Then divide by 2, sine of x is equal to negative 1/2. So then we're looking for where on the unit circle do we get the y value to be negative 1/2. And the y value is negative 1/2 in a couple of different places. It is negative 1/2 first at 210 degrees. And then secondly, it's negative 1/2 at 330 degrees. Now, notice that based on what it was asking us for, we were only going from 0 to 360. That's in terms of degrees, so I'm not going to bother with writing the answers in radians. Also, we're not going to go ahead and put the plus and minus 360 degree k or 2 pi k. We're just going to focus on just the unit circle, one rotation, just to make it a little bit easier and the notes go a little bit quicker. Okay, so let's take a look at B. We've got 2 sine squared x minus 1 is equal to 0. So solving this one, start by adding the 1 over, then divide by 2. And then we need to, instead of squaring each side, take the square root of each side. So that would be sine of x is equal to plus or minus the square root of 1 is just 1 over the square root of 2. Which then we could probably rationalize a little bit here, multiply by the square root of 2 over the square root of 2. That leaves us with plus and minus the square root of 2 over 2. So we're looking for sine of x, our y values once again. Where are the y values on the unit circle? Equal to either positive square root of 2 over 2 or negative square root of 2 over 2. And that happens at 4 different angles, at 45 degrees, 135 degrees, 225 degrees, and 315 degrees. Okay. Last one here that we are going to look at is square root of 3 tangent of x plus 1. So when we are looking at square root of 3 tangent of x plus 1, let's go ahead and solve for tangent of x. So that would be square root of 3 tangent of x is equal to negative 1, and then divide by the square root of 3 gets you that tangent of x is equal to negative 1 over square root of 3. And then again, let's rationalize that, would become negative square root of 3 over 3. And for tangent of x, we're looking at y divided by x, so we're looking at sine divided by cosine. Again, with that, it's probably best if you had already written down tangent on your unit circle to know what those values were. Makes looking at your circle a little bit easier. That actually happens at 2 different places. The first of which is at 150 degrees, and then tangent repeats every 180, so the next one would have to be at 330 degrees. Okay, so we're still going to be using a lot of those concepts today. We're just going to be using them in some extra kind of properties and using some extra strategies in order to do that. The first of which is our good old friend factoring. So if you thought that factoring was gone, we've been using it ever since Unit 4. I wasn't kidding when we'd be using this all the way up until the last day of school. Factoring. If you've been keeping count at home for how many times I say factor it, hopefully I've hit my 100 mark at this point. But yeah, factoring can actually be used to solve trigonometric equations as well. The steps to doing that. Step number 1, substitute the trig function for some other variable. So x, y, z, q, r, l, p, whatever you want it to be. Number 2, solve the remaining equation. So factor it, solve it, good to go. Number 3, substitute your trig function back into the solutions. And then step number 4, solve that equation for the remaining variable. Okay, so we're going to solve each of these on the interval 0 to 360 degrees by factoring. So in example A, we've got sine of x as our basic function. So let's let sine of x equal, we're already using x, so let's just call it w. So that means that you could rewrite this equation as w squared minus 2w minus 3 is equal to 0. I think we actually saw this way back in Unit 8 with exponent and logarithmic equations. We actually saw some exponential equations using a similar type process to what we're doing just now. So if it looks familiar, we have seen something kind of like this before. Okay, so now let's work on our factoring. I believe we could factor this to be w minus 3 and w plus 1 equal to 0. So then that's going to give us two solutions. It's going to tell us that w can equal 3 or w can equal negative 1. Now what we're going to do, since we've got w by itself, is we're going to take sine of x and put it back in for w. So we're going to have two equations. We've got sine of x equals 3 and sine of x equals negative 1. Now looking at your unit circle, sine of x never actually gets to be 3. In fact, the largest value you can get is either 1 or negative 1. So for this first equation, there is no solution. For the second equation, sine of x equals negative 1, we're looking again for where would our y value be equal to negative 1. And that happens at one place on the unit circle. That happens at 270 degrees. So in this case, our equation only had one solution. Okay, let's do another one here. So we've got in part B, 2 cosine squared x minus 5 cosine x plus 2 is equal to 0. So this time, let's let cosine of x, which is our trig equation, be equal to, let's go ahead and just use y. Why not? So plugging that in, we're going to have 2, this was cosine squared x, so 2y squared minus 5y plus 2 is equal to 0. And so then you can factor this however you'd like to. If you like to use guess and check, you can do it that way. If you like to set up the x, you can do it that way. I'll just use guess and check since it shouldn't be too bad to work through. You know you'd have to have 2y and y for the beginning of the parentheses to get a minus 5. Let's get minus 4 there and minus 1 there. So that should work to then multiply still to be a 2. And so then our two answers, when we set those each equal to 0, is y is equal to 1/2 and y is equal to 2. So then let's go ahead and put cosine of x back in. So now we are looking for where cosine of x is equal to 1/2 or where cosine of x is equal to 2. Cosine of x equal to 1/2, that should be where your x values on the unit circle are equal to 1/2. That should be at two different places, which are at 60 degrees as well as at 300 degrees. And then for cosine of x equals 2, again, 2 is not on the unit circle. In fact, it's much too large, so we're not going to get any solutions from that equation, which means we're only going to be able to use those first two solutions we found, which were that x equals 60 degrees and x equals 300 degrees. Now, as you work through these, you might find that you don't even have to do substitutions anymore. So let's take a look at C, where we've got tangent squared x minus 3 tangent of x plus 2 is equal to 0. And really what you're trying to do is you're trying to just factor these. The only difference is instead of using a variable, you just use tangent of x in its place. So we'd be multiplying tangent of x. We want minus 3 in the middle, so minus 2 and minus 1. And then we set each of those equal to 0 and solve, so we'd have tangent of x equals 2 and tangent of x equals 1. In this case, tangent of x equals 2. We're going to actually end up with a solution. You can actually have a tangent be equal to 2. However, it's not going to be an exact solution on the unit circle. So it'll be the inverse tangent of 2 is equal to x. That actually will be a solution. You could find a decimal for that if you wanted to. The other one for where tangent of x is equal to 1, that happens at 2 different places. That happens where x is equal to 45 degrees and where x is equal to 225 degrees. So you actually end up with 3 solutions, one of which is going to be a decimal. So I'm going to leave that as inverse tangent of 2 and let you find the decimal for yourself. The other 2 are exact answers, so 45 degrees and 225 degrees. All right, so in addition to factoring, you might have to use some trigonometric identities in order to solve some other equations. So that was kind of why we wanted to look at those trigonometric identities, is that they are useful in helping solve some equations where you can use them to kind of help yourself out. So let's solve each of the following trig equations on the interval 0 degrees to 360, starting with A. All right, so on example A, we've got sine of x is equal to tangent of x. Let's just start by rewriting tangent of x as sine of x over cosine of x. And then let's do this. To make these fractions kind of work out nicely, let's put sine of x equal to 1. So now this equation will be true anytime the numerators and denominators are equal to each other. So if you're thinking about it, when does sine of x equal sine of x? Well, that happens all the time. Really not anything we can do there. So really this equation is satisfied as long as 1 is equal to cosine of x. And so that'll actually be our new equation that we will want to work with. So when we're looking at cosine of x equals 1, let's look to see what that value would be on our unit circle. So where our x value would be equal to 1, and that actually ends up being right at 0 degrees. Okay. So looking at example B here, we've got sine of x plus cosine of x is equal to 0. So let's do this first. Let's go ahead and just subtract over the cosine of x so we can kind of set it up like we did before. And that should be negative cosine of x. So this looks kind of like the equation that we had before, although slightly different. Let's do this next. Let's divide each side by sine of x, or by cosine of x. So divide the right side by cosine of x, divide the left side by cosine of x. So now we've on the left side have sine of x divided by cosine of x is tangent of x is equal to cosine of x divided by cosine of x. It was negative, so negative 1. So now we just have to solve where is tangent of x equal to negative 1, and that happens in 2 different places. That happens at 135 degrees as well as 315 degrees. Okay, now we're going to do 2 more kind of like that. They do use a different identity. So 2 identities that we did not discuss back in section 12.1 are what are called the double angle identities for sine and cosine. So here those are. If you have sine of 2x, that is the same as 2 sine of x cosine of x. And then if you have cosine of 2x, that is the same as cosine squared x minus sine squared x, which is also the same as 1 minus 2 sine squared x, which is also the same as 2 cosine squared x. So when you've got cosine of 2x, you actually have 1, 2, 3 different expressions that you can use in place of cosine of 2x. So let's use these identities to solve a couple more problems. The first one, we've got cosine of 2x is equal to cosine of x. So in deciding which of those 3 expressions to use that'll be most useful, if you've got cosine of x over on the right side, you probably want to pick the expression that has just cosine of x in it, which rules out number 1 because it also has the minus sine squared x. Number 2 you would probably use if it was sine of x on the right side, but it's not. So let's use that third expression as our replacement for cosine of 2x on the left side of the equation. So that would be to say that 2 cosine squared x minus 1 is equal to cosine of x. Okay, and then from there, let's get one side of our equation to equal 0. So let's subtract the cosine of x over to the left side. And then we can start to try to factor this. So I'm going to go ahead and do the substitution. So let's let z equal cosine of x. So now our equation looks like this. We've got 2z squared minus z minus 1 is equal to 0. And now let's work to factor that out. So let's see here. We're going to definitely have to have 2z and z. There's no way around that. We've got to have 1 and 1. Let's do minus 2 plus 1. That way we get a negative z in the middle. So then our two solutions, at least for right now, are going to be that z is equal to negative 1/2 and that z is equal to 1. Now that we've got z solved for, let's solve for cosine of x. So cosine of x equals negative 1/2 and cosine of x equals 1. So looking at your unit circle, cosine of x should be negative 1/2 in two places. That would be at 120 degrees as well as 240 degrees. And then for cosine of x equals 1, that would only happen at one place. That would happen at 0 degrees. So in this case, you're going to end up with 3 solutions. Okay, one more to look at here. So in example D, we've got cosine of x multiplied by sine of 2x equals 0. Now for sine of x, you've only got that one choice to look at. So we're going to have to just go ahead and use that for now. So that would be that cosine of x multiplied by 2 sine of x cosine of x is equal to 0. Okay, let's do just a little bit of rearranging, especially on that left side. Let's move the 2 out in front for now. Then we'll move sine of x with it. And then cosine of x happens twice, so it's being squared. So now here's your equation that 2 sine of x cosine squared x is equal to 0. Which then the 2 really isn't important. You can divide each side by 2 and then say that sine of x multiplied by cosine squared x is equal to 0. Which really means that one of two things has to be the case. Either sine of x has to equal 0 or cosine squared x has to equal 0. Which really for cosine squared x equals 0, that just means that at some point cosine of x has to equal 0. Okay, so looking at your two main equations, one of which is right here, the second of which we've simplified to be right here. Sine of x is equal to 0 in exactly two places. That happens when you're at 0 degrees as well as when you're at 180 degrees. Cosine of x also happens to be 0 at two places. Those two places are at 90 degrees as well as at 270 degrees. So in this case, we're actually going to end up with 4 solutions. All right, that is it. That is it for Unit 12. That is it for Honors Algebra 2. Good luck if you're choosing to take the final next week, and I'll make sure to get those grades put in for you guys. Besides that, have a great summer. Hopefully you can get out and have fun like you normally would. And I will see you next year, hopefully in the hallways. Don't be a stranger. Feel free to stop by. Good luck in either College Algebra Trig or Honors Pre-Calc, or for those taking IB Math, good luck in those courses. If you're interested in taking either regular stats or discrete math, feel free to talk to me about that. Shoot me an email about getting enrolled, and we can possibly get you in those. And have a great rest of your day. I will talk to you next time.